Hi, welcome to class. My name is Don Lafond, Professor Don, and this week in Cisco 1, we are covering Module 10, Basic Router Configuration. Relatively easy presentation because you'll see in a few minutes that router configuration is much like switch configuration, which we've done previously in this course. I am going to go ahead and share my screen. If you have any questions and you're here with me live, please hold your questions until the end of the presentation, and I will allow for a question and answer period at that point. If you are watching our presentation, my presentation, online as a recording in NetAcad, please ask your questions in the help discussion forum. And if you're watching it on YouTube, please ask questions down in the comments below the video, and I'll do my best to answer those questions. Although it's best if you guys help each other as well. All right, here we go. So today we're going to talk about basic router configuration. We're going to implement initial settings on a router and end device using an iOS router software. We're going to configure 2 active interfaces on that router, and we are going to configure devices to use the default gateway. So this is the basic configuration for a router. You should think to yourself that this looks an awful lot like the basic configuration of the switch. I recommend that you write these notes down inside of your tech notebook or however you're taking notes if you're out there in the real world. I recommend you write down these commands exactly because these commands should be the commands that you do as soon as you open a box and take a router out of a box. This is what you should do immediately on every single router. All right, so we got to set a host name. That's the device name. So everything isn't named router. Even if it's router 1, 2, 3 or router first floor, second floor, third floor, it allows for you to know when you SSH or telnet into a piece of equipment which router you're actually working on. Because otherwise they all have the same default name. Then you put a password on privileged exec mode with the command enable secret and then whatever password you want it to be. Then let me put on my laser pointer. And then you configure a password on the console line, and that is line console 0, and then password, whatever the password is, and then how you want to store it. In Cisco 1, we only store it on a local database. In Cisco 3, we learn how to store our passwords remotely on a authentication server. Then you set your virtual lines. Notice we're setting only line virtual 0 through 4. Again, that's 5 virtual lines. That's 0, 1, 2, 3, 4. That's 5. 0, 1, 2, 3, 4 is 5 virtual lines. You give it a password, and then again, you store that in the local database. And then you say whether you want it to be SSH, Telnet, or both. Remember, Telnet is insecure. Actually, Telnet is not insecure. Telnet is not secure. It's probably very confident in its own personality, but it is insecure. All of the password, all of your typing on Telnet is all, you can use Wireshark and you can see it clear as day. And that's even with setting our password down here, because this service password encryption encrypts the console and the VTY line passwords. And then you set a banner message of the day. Remember, the message comes between 2 symbols, and those symbols could be asterisks or pound signs or exclamation points, whatever. As long as in your message itself you don't have that symbol, like you can't use an exclamation point at the beginning to start it, and then at the end of your sentence, go away, exclamation point. Well, the exclamation point won't actually show up. It'll just say go away because the exclamation point will end the previous. We talked enough about that. You already got in practice with that on switches. So here is actual commands that have been here are the actual commands as typed for an example. So we have hostname R1, We have enable secret. The secret they're putting in there is class. We're signing into our console line, and we're putting a password Cisco on that console line. Then storing Cisco in the local database. We're signing into the configuration mode for our virtual lines and for 0 through 4. We're setting the password to Cisco. We're storing that locally. And then here you'll see transport input SSH and Telnet. They're allowing for both. Now, I've been specifically told that you will not see Telnet configured in the real world because they, in production environment, because it is not secure. So you should only be using transport input SSH, but just do whatever the labs tell you to do. That's the important thing. Exit out of that, and then you're setting service password encryption. This command encrypts those passwords. And then your banner message of the day, I think they're actually missing a command line because it starts it with this symbol, right? But you don't find that symbol anywhere in here. So I think they're actually forgetting to end it. And I'm not exactly sure how that would actually work. If you don't put the end, then it doesn't know when the end is. So maybe you can mess around with that and remind me what happens, because I think this is just a mistake and I should fix it at some point, but I just haven't done it yet. Then you exit out of there, and then you do copy, run, start. The whole command is copy, running configuration, startup configuration, but generally students just type run, copy, run, start, and that puts the running configuration in NVRAM. So when you reboot the computer, all of these security configurations will remain and be enabled when the router or the switch starts back up again. See, easy. Nothing hard about here. Nothing hard here. And you're going to do a packet tracer to set those commands and then to verify the router configuration once you're done with it. Now, this may be a little new, but we did it in a switch. Remember, we configured VLAN 1 as an SVI, switch virtual interface. And by configuring an IP address on VLAN 1, we were able then to telnet into the switch for management purposes. So we can configure ports on the switch. And we'll learn more about security and configuring ports later on in this course and in Cisco too. But the important thing is, when you take a switch out of a box, it is ready to go. You do not have to configure anything on it. Everything is up. You plug some computers on and they are talking. That is not true for a router. A router comes out of the box with nothing configured and everything down. So if you connect anything to the router, you have to give the router port that you're connecting it to information about what it's connecting to. For example, you have to give it an IP address in the range of the network that you are connecting to the router. We'll see that in a moment, in the next slide, actually. So remember, a switch is ready to go when you take it out of the box. There's no security on it, but you can plug things into it and it's ready to go. A router, on the other hand, will not work at all if you plug everything up and turn it on without getting into it and configuring the ports. Nothing will work on the router. Okay. They also mentioned here, you go into whatever the interface is. So interface G00 or interface FE01 or serial 000. That's the interface that you're going to configure. And then description, it's a good idea. This is an optional command, but it's a good idea later when you're looking at the running configuration, what networks are what ports are what. It's helpful to have a description there. Also, if you go into the port and do a show interfaces command, you can see what the description is. Not necessary, but it's a nice thing to have. Then you give it an IP address, you add the subnet mask. If you want an IPv6 address, you got to put that in there, /64, which is the normal prefix length. And it's always, I think it's always that way in this course. And then no shut. Again, remember, a router is down until you bring it up. So the answer is no shut brings it up. Here are the actual commands on this network. I'll zoom in so you can get a better look at it. So let's look at the network first. So we're configuring this router right here. This is R1. You can see it right there. And in R1, we have the 10 network. That's here, 10.0. The router is 10.1, and the PC is 10.10. So the first configuration, you go into G000. You go into G000, and then that's interface gigabit, and you don't have to type it all out. You can just type interface G000, and then give it a description. In this case, the description they gave it is link to LAN, and then give it an IP address. Note it is 0.1 here, so it's 10.1. So that's what you type in there, and it's the /24. So that's 255.255.255.0. If you're not comfortable with subnet yet, don't worry, we have a whole week to talk about IPv4 subnetting. Then if you are giving it an IPv6 address, here we see ::1. This indicates the IP address is one in this network, and notice it's a /64, which is normal for IPv6. And so you type that in here, IPv6 address, 2001 DB8:ACAD:10. There's the network, ::1. There's the port, /64. Again, that's the normal, but not always. It could be different. But no, that we'll get into it later. But that gives us a lot of addresses to hand out. So /64 is the normal. It also has to do with how addresses are automatically handed out, and we'll learn that later on as well. Then no shutdown to bring up that port, and then you exit out of there, and then you can see that the interfaces start coming up. Now we are then going to go to the other side of the network, that same router, I should say, and now we're dealing with this side, and notice it's a 224 network /30. And so 224 means the first address is 225, the second address is 226, and 227 is the broadcast. It's often and common to use a 30 network when we're talking about serial interfaces, point-to-point interfaces between routers. You only need 4 addresses, right? The network address, 2 addresses for each side of the connection, and then the broadcast address. Here is the network. It's the 224 network, ::1. So when we're configuring this side, it is gigabit Ethernet 001. There it is, right there. And then description link to R2. R2's over here. IP address. This is 225. So you'll see 209.165.200.225. And then the subnet is 255.255.255.252. That's a /30. You'll learn that by the end of this course with practice, hopefully. Then here is the IP address, again, :1 in this address with a prefix of 64, and then no shut to bring it up. And then now this whole interface is going to come up, and you can see that that you have come up, and we'll see some show commands to prove that in a little while. All right, that's it. That's the configuration. And as I said, that may be new. In the past, what they did was they fed you the information. They didn't expect you to understand it, but now you're supposed to understand it in this chapter. Now, once you've configured your router, of course, then you would go and configure R2. We're not going to do that in this presentation. We're going to assume that it is already configured. Now, the next thing we're going to talk about is verifying those commands, verifying that the system is configured properly. So the commands include show IP configuration brief or IPv6 interface brief. I know I've said this before. When you see a show IP, always in your mind think IPv4. Anytime it's show IP, whatever or anything dealing with IP, that's IPv4. Just remember it that way. It's just IPv4 came around first, so you didn't have to be, they don't have to type IPv4 whatever. I think they should write that into the commands. Just add it so students, I could start teaching it that way, but that is that you cannot put IPv4 in there and have it actually work. It'll give you an error message. So if you want to display all of the interfaces with their IP addresses, but just in a brief layout, that's what you use. Show IP interface brief. The next thing you want is the routing tables for IP routing table, which is IPv4, and IPv6 routing table, and you'll see that there. Then show interfaces. That gives you a huge printout of everything about every device that's an IPv4 related, nothing for IPv6. If you do show IP interfaces, then you're going to get information statistics for just IPv4. And if you do show IPv6 interfaces, you're just going to get information for IPv6. Now, these should be written inside of your tech notebook under a page that is just show commands, and you should just keep adding to those show commands as you move through all of your courses. There's, I don't know, 100 of them. Some of them are super easy and you'll get used to, like the show IP route. Some of them are very complex that I'm not even going to throw any out at you right now, but they are very complex and should be written down because you use them so rarely then that you should definitely configure. Definitely write them down so you have those notes when you're configuring or verifying your connectivity. All right, so here we're going to do a show IPv brief. I'm going to zoom in. So notice this is for IPv4, this is IPv6. It gives you a brief layout of your interfaces. We configured both of these. We configured both of the IPv6 interfaces as well. Notice that we are, in addition to the actual port that we configured, 10.1 and 224.1 for the IPv6 interfaces, notice that two other addresses were automatically added. Those are link local addresses. Think of link local addresses, private addressing. It like IPv4, link local addresses only happen inside the network that they're in, so they can be duplicates, but they are they're never outside address. Well, I shouldn't say that. Most of the time they're not outside addressable, and they are just used for inside of the device communication. Like a PIPI for Windows. If you don't have a network or router configured to a Windows network, you bring it up, it gives itself addresses and it can communicate within its own network, but it can never get out to the internet. If you guys are familiar with a PIPA addresses, you know what I'm talking about. Kind of like that. It's never, those addresses are not intended to be sent out to the world. But every port an IPv6 has those addresses so that they can communicate within the network. All right, we'll go with that. Okay, you can see they are up. We are up and up, and we are up and up in IPv4, and we are up and up in IPv6. We did a good job with configuring. Now we can also see the routing table, and we've seen the routing table before. The routing table is, remember, directly connected. I think we had a video where they showed you. Here is the network. You can see it's directly connected to the 10 network and to the 224 network. And the port that's configured is 10.1 is for the 10 network. That's the router interface IP address. You can tell it is because it's a 32 indicating one address. 24 indicates 255 addresses, right? We'll talk about that later. Down here we have in IPv6, we have a 224/30, that's the network, and 225 is the IP address. This indicates it is the link address. Link address, and you got a couple local link networks going on as well. Now, you can also go in and look at an individual port, show interfaces, and then whatever port you want to see. Why is this guy not working for me? Here we go. And just to zoom in a little bit, it gives you statistics. Again, it tells you that it is up and up. Also, it's good information in here, the MTU size. Down here, the media type, it's RJ45. Oops, sorry. It's RJ45, so it's copper. Let's see, it doesn't have it's received 84 broadcasts and no errors. All right, just basic information. If you start seeing a lot of errors, we'll either talk about that. No, we already talked about what happens when you get runts and baby giants and all that good stuff. We talked about that earlier. Look it up if you don't remember. Here is show IP interface. It shows you some additional information. A lot of the same stuff, not exactly the same stuff. So if you're troubleshooting, there are times when you want to show interfaces gig 000, and then show in IP, which is just IPv4 again. Actually, this is just IPv4 as well. This is IPv4 interface, and then a specific interface that you want to look at, and then you have IPv6 and specific information. You can see here, for example, it's joined this unicast and some multicast addresses, and duplicate address detection is enabled. We'll talk about that later, and neighbor discovery and the time that it repeats. All that information about one specific port. Now let's talk about configuring the default gateway. So remember, a default gateway is only necessary when you want to reach outside of your network. If you just want to talk inside of your network, inside of the 10 network, then you do not really have to have a default gateway set, because these two devices can just talk through the switch using ARP. They can discover local IP addresses of other devices on the switch, and it can send traffic within the switch, within the same network, no problem, that works. But how common is that, right? It would be, for example, in our class, if we're meeting in person, you could have 24 computers and you could talk within each other, but none of you could get to the internet. But you could talk within each other if you wanted to, no problem. You could ping each other, no problem, but you couldn't ping the next classroom over. At home, I could send a message directly to my wife's cell phone, I guess, if it was IPv4 enabled. But it's unlikely that I would do that. I would probably go out, well, I would have to be, first of all, using Wi-Fi for that to happen. Otherwise, it's going to go out to a cell tower and come back. But most likely, I'm going to be leaving the network and coming back. Now, in order to leave the network and get to another network, you have to set a gateway on a host. So, the gateway is used when the host sends packets to another device or network. The default gateway address is generally the router interface. Remember those G01, G000 10.1. This is the default gateway for the 10 network. This is the default gateway for the 11 network, right? And once you configure PC1 and PC2 with 10.1 as the default gateway, now it will be able to reach out into the world, assuming there was another line over here. Once you configure PC3 and 4 to have 11.1 as the default gateway, now these two computers will be able to reach the outside world, and PC1 will then be able to reach PC2. Now, even this is not completely new, because remember, back in when we talked about a switch, we enabled default gateway on the switch as well. Remember the SVI. Remember, we went into interface VLAN 1, we gave it an IP address and a subnet mask, and then we brought it up. Then we had to give it a default gateway, IP default gateway 10.10.1. If we don't, and it's just another IP address, it's the router, the same place, it's still this guy. The switch still needs this default gateway, and I'll tell you why. If another device out here in the world wants to telnet into this device, right? It's on the next page actually. If I want to configure the switch through SSH or telnet, without the default gateway, I would be able to get to the switch. I would be able to see that my commands would be able to get to the switch, but nothing would come back to me because there would be no default gateway. So I would be able to hit the switch with my commands, but it would look like the switch is not responding to me. And that's because nothing could get back out to me because there would be no default gateway set. So I would hit the switch, but then the commands would not come back to me because I would not have a default gateway on that switch. You can see the commands to see if a default gateway has been configured on the switch by doing a show running config. Notice that we're on switch 1. All right, here's a video that will introduce you to the routers that we use in our labs. And then the next video, part 2, is actually going to configure a router. And I really like that video, but it's also important, especially if you're watching this at home, to see what the routers actually look like when we talk about a Cisco 4000 or 2900 or what the switches are. So let's see this video.
Hello everyone, we are here to talk about the Cisco routers and switches that you may find in the classroom near you. Now more specifically, we're going to focus on the Cisco 4000 series router and the Cisco 2960 series switches. With that regard, the Cisco NetAcad curriculum is utilizing the exact 4221 model Cisco router and the 2960 Plus series switch. We're going to take a look at a couple of different network devices because what you may have in your classroom, it might be different. So let's talk about the interfaces and the different expansion slots that you may find on a Cisco router near you. The first router we'll take a look at is the Cisco 4000 series router. And this router right here is actually a 4321 router, which is different than the 4221 router. But let's take a look at what is equipped on this Cisco router. We've got what are called our integrated ports. That would be our gigabit interface 001 and our gigabit interface 000. We'll take a closer look in a second, but those ports are built into the Cisco router. On the right side here, we have these NIM slots. That's network interface module slots. These are expansion cards that we install on our router. This card allows us to have serial cables plugged in using serial interfaces. Now, for a closer look at this router, we can blow up this picture and say, there's a gigabit 000 that's shared. There's a yellow line that connects 2 ports, and that is correct. This gigabit Ethernet 000 interface actually allows us to either use the integrated copper network interface connection or our SFP, where SFP stands for small form factor pluggable. That is a module that allows us to plug in a fiber transceiver in this example. And even on the right side, there's a closer view here of our network interface modular slot, which is our expansion slot, those serial cables plugged in. That being serial 0, for example, on the NIM card slot. Continuing onwards, we'll take a look at a Cisco 2900 series router, and this is a big, beefy 2-rack unit router, 2 racking 5. If you take a look at the height of this thing, we see that we have our WIC card slots, just like we saw with a network interface module in the last router. WIC stands for WAN interface card. These are EH WICs, which means enhanced high-speed WAN interface card slots. I've got two of these WIC2Ts, which are WAN interface cards using serial cables connected. And on the right side here, what we'll see with this 2900 series router is I've got multiple integrated gigabit Ethernet ports. I've got gigabit Ethernet 00 and 02. Then down below here, we've got gigabit Ethernet 01. And again, this yellow line down here is showing that we are sharing the SFP transceiver port with the Gig 02 copper Ethernet port. When one's in use, the other can't be used. So this is allowing us right now to have a fiber connection, which can literally be an uplink to another device. Let's take a closer look at that. You'll see the Gig 00, Gig 02 with our copper Ethernet plugged in. You'll see that Gig Ethernet 01, which is that shared port for that copper, as well as that SFP transceiver. And there on the left side, we see that enhanced high-speed WAN interface card known as the EH-WIC. And that is where we have our serial 0 and our serial 1 cable plugged in accordingly. Now, this router is the Cisco 1900. You may see this one in your topology with what you have. And with this, we have, again, our enhanced high-speed WIC slots. This has less space than what we saw in the previous router. And also, we only have two of our integrated gigabit Ethernet ports. For a closer look on that right side of the router, you can see the gigabit Ethernet 00, the Gig Ethernet 0/1, as well as our enhanced high-speed WAN interface card with our serial cables plugged in. Serial 0 being the bottom one, and serial 1 being the top port. So regardless of what you have in kind of your area with your network equipment, we're going to try to focus on the Cisco 4000 series as well as the Cisco 2960 series being the equipment of choice. But keep in mind that classrooms may vary, and it's important that you understand the equipment that you will be utilizing. So get started, take a look at your equipment, and let's make the best of using Cisco routers and switches in the classroom.
All right, great. Let's run right into the next video, and you'll see that it is very useful.
Hello everyone, this is part 2 of our network device overview, and here we're going to focus on the configuration of a variety of routers. Now the Cisco routers we're talking about here are going to be the Cisco 4000 series, 2900 series, and the 1900 series routers. Now, CCNA version 7 labs were built and designed using the 4221 Cisco router and the 2960 plus switch. Here we're going to talk about the variety of Cisco routers that you may find in a classroom because the equipment.
Sorry, that's the same video.
Hello everyone, this is part 2 of our network device overview, and here we're going to focus on the configuration of a variety of routers. Now the Cisco routers we're talking about here are going to be the Cisco 4000 series, 2900 series, and the 1900 series routers. Now, CCNA version 7 labs were built and designed using the 4221 Cisco router and the 2960 plus switch. Here we're going to talk about the variety of Cisco routers that you may find in a classroom because the equipment you have might vary. So let's get started, and we're going to hit router 1 first, which is the 4000 series router. In our topology, we've got a Gig 001 interface going down to a PC. We've got the Gigabit 000 interface using a SFP small form factor pluggable fiber transceiver. We've got the serial 010, which is utilizing a NIM, the Network Interface Module expansion slot with a serial card installed. So let's get started inside of the operating system and take a look at these interfaces using some show commands. The first show command to know is going to be our show IP interface brief. And with this modifier of brief, we'll get an easy yet very, very beautiful output for our interfaces that we have deployed. On this 4000 series router, we've got Gigabit Ethernet 000, as is displayed in the topology. They've got Gigabit Ethernet 001, which is also displayed in the topology, connecting down to PC1. They've got serial 010, which is using our Network Interface Module expansion slot, which has a serial card installed. Also, we've got serial 011, which is not in use, and then there's a Gigabit Ethernet 0 as well. Well, let's take a closer look at this Gigabit 000. And to do this, we'll use the command show interface, followed by that exact port, which is Gigabit Ethernet 000. And when I hit enter, I want to show you something that's very important here. This is going to be a fiber connection. But how can we see that on the router? Well, inside of the output for our show interface gigabit Ethernet 000, we can look for something called media type. And here on this line, we'll be able to see that we're running full duplex 1 gigabit connectivity, and media type is SX. This is very different than taking a look at an RJ45 copper Ethernet connection. We can compare this gigabit Ethernet 000 port to the gigabit Ethernet 001. Let's do that next. I'll do another show command, and this will be show interface followed by gigabit Ethernet 00/1. And let's take a look at the media type of this port. We see the line full duplex again. We see a speed. And then at the end of that, we see media type is RJ45. This means that we're talking copper Ethernet connectivity as compared on the last port, which is SX, which is using a fiber transceiver. Awesome. So for us at this time, we should do a small configuration to have these ports up and running, both with IP addressing and activating. To do that, let's play with the fiber port and go from there. I'm going to enter my global configuration mode because this is where I make changes on the router. And to do that, that's the command config space T. Now, config space T doesn't do anything until I hit the enter key. So I'll hit enter, and you'll see my prompt change to my global configuration mode. Now in this mode, I can use my command interface gigabit Ethernet 0/0/0. And once I hit enter, I'm now configuring that fiber transceiver. For me, I'll put an IP address on. We'll make this easy. I'll put a 10.0.0.1, and I'll give myself a subnet mask, ending with a 252. You can see that I shortened the word address to just add, and it'll take this command just fine here. When I hit enter, the IP address is applied, and I'll use the command no shutdown to bring this fiber transceiver up. Interface gigabit 000 is now configured. So let's head over to the 2900 series router and take a look at bringing this fiber link up on the other side. And what we're going to notice is those port identifiers, they're rather different. So here on the 2900 series router, we're going to start just like we did on the 4000. Let's use a popular show command, and that's show IP interface followed by the modifier brief. And with this, we'll be able to see all the ports on our router and their corresponding interface identifiers. For example, we've got 3 gigabit Ethernet ports on this 2900 series box. And we have gigabit Ethernet 00, 01, and 02. This is very different than what we saw in the 4000 series, which is gigabit Ethernet 001 and 000. So keep in mind, these interface identifiers are going to change based off of the model of your device that you're using. Also, they'll change based off of your expansion slots. For example, on this 2900 series router, is not shown in the picture, but there are 4 serial ports available on this box using the enhanced high-speed WAN interface cards. So for us, let's focus on that gigabit Ethernet 0/1. I'm going to go into my global configuration mode. Again, this is where we're able to make our changes on our router. And with that config T command, hitting enter, we have moved into the configuration mode. Now I can go into that interface with the command interface gigabit Ethernet 0/1. When I click enter, we are now in our config if mode for that port. We're going to configure this thing. I will put an IP address of 10.0.0.2 because the other side was .1. And again, the corresponding subnet mask. Now we need to bring this port online, so we'll use our no shutdown command, and I'll hit enter, and we'll get some status changes that are going to occur here. Our gig 01 is coming up. There it is. And we'd like to verify the media type of this interface, just like we've done on the other side. So I'm going to type in end. That'll take me back to my privilege exec mode, that pound sign we see there. And I'll use my show interface, followed by gigabit Ethernet 0/1. That's a verify this. And what we're looking for here is going to be media type. And if I scroll through this, we'll see that we've got full duplex. All right, that's great. 1 gig per second speed, that's awesome. And there it is. Media type is SX. This is different compared to RJ45 that we saw previously on the 4000 series gig 001 port. So let's go into our gig 02 interface on the 2900 series and finish our deployment, and then hop into the 1900 series. I'm going to go back into my configuration mode, which is using config T. I'm going to go into my interface, followed by gigabit Ethernet E02. Awesome. And now in gigabit Ethernet 0/2, this is the port on the right side of the 2900. I'm going to put an IP address here. And for this, we'll do IP address followed by a 172.16.0.1 and same subnet mask as before. To bring this interface online, we'll use our no shutdown command. And now this port is also configured. So let's take a look at our third router, which is going to be our 1900 series, and do some configuration over there. On our 1900 series router, we're going to start it just like we've done before, a show IP interface brief command. From here, we can see our port identifiers. They're very similar to the 2900 series, gigabit Ethernet 00 and 01. You notice we actually have less ports here on the 1900 series. It is a different model than the 2900, and it's a little bit smaller. So we've got 2 gigabit Ethernet ports, as well as I have an expansion slot in use with that high-speed WIC card slot, and that's for those serial lines. We're going to use the gigabit 01, which connects us over to the 2900 series. So we're going to enter our configuration mode with config T, and then we'll go into our interface, followed by gigabit Ethernet 0/1. Inside of here, we'll finish our addressing with an IP address 172.16.0.2, because the other side was 1. And we'll use our subnet mask of all 255s ending with a 252. We need to make sure this interface is activated, so we'll use our no shutdown command, and we'll get some status messages populating here. When everything is up on our side of the house, we'll do some ping tests and make sure we have connectivity to the other side. To do those ping tests, I'll type in end, and now we can ping 172.16.0.1, which is gig 02 on the 2900 series router. First one might fail due to ARP, the last are successful. We can run that command again and see a full 100% success. To close it out, let's ping across that fiber link as well. Let's go back to the 2900 series and make sure we have full connectivity to the 4000 series on that fiber connection. So back on that R2 router, we're going to ping across that gig 01, and that's us having I'll verify the IP address before we say it, show IP interface brief. That's us having the 10.0.0.2 IP address on our side, and we're going to ping the other side, which is 10.0.0.1. And ping is an awesome network testing tool. This is how we can test our network connectivity between devices. When I hit enter, I want 5 success, but we might have 4 only because of ARP. So ARP has successfully resolved, and we're going to fire that off again, and now we should have 5 pinging across that fiber link. So take the time to practice with the Cisco network equipment that you might have on hand at your location. While we encourage the use of the 4221 router and the 2960 switch, classroom equipment might vary. But we encourage you to use your show commands and get comfortable regardless of the model of the equipment that you're working on.
All right. I really like that video because it's really I think your first, the first time you've been exposed to configuring ports on a router and then actually configuring the network as a whole. So hopefully you understand those concepts. If not, rewatch the video. If you're in our classroom, of course, you can get at it in our NetAcad content. If you're out on YouTube, then you can go to itexamanswers.net, and they have all of the NetAcad content, including the videos. Again, that's itexamanswers.net. They don't pay me, but I know the material's there. There's other places as well. If you think they should pay me, let them know they should pay me. Just goofing around. Anyways, you're going to do a packet tracer. You're going to do connecting a router to a LAN 10.3.4. You're going to do another packet troubleshooting default gateway issues 10.3.5. You're going to do basic device configuration. And for me, remember, you're going to be filling out this table, and you will be giving it to me as a part of your submission. Make sure you fill out the table. I'll be looking for that in 10.4.3. And you'll be doing a NetLab assignment 10.4.4, build a switch and router network. And that is my presentation for Module 10. Hopefully it was informative. Like I said, not too challenging, but the material, because a lot of it you've seen when we're in Cisco, when we were in our switches earlier, we had a lot of those same commands, And I really like the flow of this presentation. Hopefully it got you to understand the concept. Of course, I still want you to review the material because that will reinforce. And within Cisco, everything builds on everything else. So you really have to understand these simple commands before we start getting into the more complex issues. They assume, for example, that you know how to configure a router, and they'll just say, configure the router with these ports, with these IP these ports with these IP addresses, and no, they're not going to walk you through that. After a little while, they're going to expect you to be able to just do it on your own. All right, great. Thank you for coming to class. My name is Don Lafond, Professor Don. It has been my pleasure to be your teacher today. If you have any questions and you're here with me live, I'll give you an opportunity to ask those questions, and I'll answer them in just a moment. If you are watching it as a recording inside of NetAcad, please ask in the help discussion forums, and all of your fellow students have already promised to help answer your questions. And if you're watching it inside of YouTube, of course, I'd like you to like and follow me. But you're also welcome to ask questions down below in the comment sections, and we will try to answer your questions. It's like and subscribe, by the way, and I do appreciate that. Anyways, thank you for coming to class. Have a great week, and I hope you learn a lot about Cisco this week.